Welcome to lesson 2.1. This whole unit for unit 2 is going to be dealing with algebra. We're going to start off with some definitions. So the first one is a variable. And when we're dealing with algebra, variables are going to be the letters. So variables are the letters. So for example, the most common one is going to be x. Also, I use N a lot, K. I'm going to try and use letters that don't look so much like numbers, but there's going to be a few times where we do that as well, and I'll point those out. Next is going to be a term. The terms are when we talked about it a bit last unit, is when we have a combination. So a combination of coefficient and variables. So the coefficient is the number out front. So we have the coefficient, that's the number out front. And then the variable are the letters, and it's the combination or the squished togetherness. So by combination, I meant also like the squished together. And they're always together by multiplying or dividing. So it's a combination of coefficients and variables that are multiplied or divided. And we can tell when a term is done because they are separated by addition or subtraction. Separated by addition or subtraction. So some examples of these could be if we have 10JL, that would be a term because we have a number out front, then the letters J and capital L. Another one could be minus 2M. And I'm going to point out that the coefficient, when we're dealing with coefficients, the sign out front goes with the number that comes after it. So that's so important. I'm going to write a little note about that the sign goes with the number that comes after it. And another example, so those had multiplying because they were squished together. But here's another one. If we did 7a over BCD, that's a term as well with a coefficient of 7 and then the variables a, b, c, d. So as long as it's separate, no addition and subtraction within the term, it's a term. An algebraic expression is the addition or subtraction of multiple terms. The addition or subtraction of multiple terms. So an example of that could be what's shown directly below there, that 3x squared minus 2y plus 10. That's one. I'm going to do another example. If I do 5mk minus 7jy plus 10w squared over d, that's an algebraic expression. And I'm going to highlight that's one term. This, including the minus sign, is the second term. And this one here, 10w squared over d, that's a third term. So this example here, 3x squared minus 2y plus 4, I'm going to zoom in a little bit. First thing I'm going to do is I'm going to put a red box around the terms. So that's one term there. And then 4 is a constant, but it's going to be a term. And then I'm just want to keep them looking separate, but I want to make sure that we include that minus sign as well. So this one would have 3 terms. And in each term, we're going to have, so the 3, and the minus 2, both of these ones are coefficients. The x and the y, so the y and the x and y are our variables. And a number by itself, we didn't really talk about this yet, but that is a constant. So it never changes. The variables vary or change. The constant, it's the number by itself, because 4 is always 4. Also, a couple more words we need to know. Monomial, like a monocle, old-fashioned, the single lens that you hold in front of your eye. Monomial, so the mono is going to be where we have 1 term. Binomial, like bicycle, is going to have 2 terms. And then trinomial, like a tricycle, has 3 terms. And finally, a polynomial means it has more than, and in this case, it's just more than 2 terms. So a trinomial is a special type of polynomial. I'm going to give some examples of these. So 1 term, an example could be 7a, right? Another example could be 2 terms, so it could be x plus 7. That could be 2 terms because they're separated by a plus sign, even though they're inside brackets. It could also be m squared plus 8m. Or we could do something with subtraction. It could be g minus GHK. That would also work, subtracting. 3 terms, trinomial, the classic one would be something where you have a number out front of x squared plus 2x plus 3. So something where you have 3 terms, the first 2 terms that have the variables in them, and then a constant on its own. But it also could be, a trinomial could be something like 10 mkv minus 2vg plus 7f. That also would be a trinomial with 3 separate terms. Like terms. So like terms are 2 or more terms that have the same variables raised to the same exponents. So like terms are 2 or more terms that have the exact same variables, and remember those are our letters, raised to the same exponents. So just reminding you that the variables are the letters. So examples of like terms. I'm just going to do, I think, 3. So I'm going to separate them with some lines. Oh, maybe I'll do 4. Okay, so our first example would be 2x squared. A similar or a like term would be minus 7x squared. So it doesn't matter what the number is out front. We're only looking that the letter to the exponent matches the letter to exponent. So an example of unlike terms would be 2x squared. And then we could go and say minus 7x. So it doesn't have the same exponent. Or it could be minus 7x squared y. So that's not a like term. It needs to have the exact same letters to the exact same exponents. Another example of like term could be 10mk, and then anything else, as long as it has an mk, it doesn't matter what the number out front is, because the exponents are the exact same. But some examples of something that isn't a like term. If I had 10k, doesn't matter, no m. 10m, not alike because it doesn't have the k. If I had 10mk squared, no way. Or if I had 10jk, none of those are like terms. Last one I want to show you, if I wrote minus 3kh, a like term to this could be 4hk, because it's the same. Well, let's make them all squareds. Squareds. Now let's make the h a cube. So as long as the h stays cubed and the k stays squared, the order doesn't matter. So that's why I've put this one in here. Order of the variables or the letters doesn't matter. So if I had minus 3k squared h3, some examples that are not or are unlike terms, if I had minus 3k h3 or minus 3k squared h squared, anytime where you don't have the exact same letters with the exact same numbers, order doesn't matter. It's the exponents and the actual letters that matters. Okay, so that's it for reviewing stuff. One of the new things in this lesson 2.1 is going to be learning about a degree. So the degree of a monomial, we'll start with that. And monomial means we have one term. Just a reminder. Polynomial is going to be more than one, right? Sorry, two or more. Two or more terms. So the degree of a monomial, so that's just one term. We're going to take the exponents, we're going to take the variables, look at what their exponents are, and then add them all up. So we would be finding the sum of all the variables' exponents. So the sum of them. So here's an example. So example 1, if we have 7x squared y to the 3, then the degree would be, I'm going to have to look at the exponents. So I've got a 2 and I've got a 3, and I'm going to find the sum, so I'll add them up. So the degree of this term is 5. Here's another example. If I have m to the 10, n, p to the 3, first thing I need to remember is that n really does have an exponent. You can't see it, but it's like that ghosty or invisible one. And now that I know what all the exponents are, I'm going to find the sum of them for the degree. So the degree would equal 10 plus 1 plus 3. And in this case, the degree of that monomial would be 14. Now the degree of a polynomial, we're going to find the maximum of each term's, let me write it down first. The maximum of each term's degree. So you're going to find each term's degree, and then whoever has the biggest one, that's going to be the degree of the whole thing. So, and that's after you determine each term's degree. So that's the first thing you'll have to do. And just a reminder that when we're doing all of these, we're only looking at the variables or the letters. We're not looking at the coefficients. Not the coefficients. Okay. So we're going to state the degree of the following. We've got a bunch of monomials. So we're going to look here. We've got an exponent of 3. So that means my degree equals 3. Here, I've got x, y. There's an invisible exponent of 1 on the x because it shows up one time, and y also has a 1. So I'm going to add those two exponents, and the degree of this one would be 2. Now, I was ignoring the 3 or the 4 out front, ignoring that coefficient. So for this one, ignore what's out front. I've got a 3, and I've got 1y. So the degree of this one would equal 4. And then 7, well, that's just a number out front, and I would have to ignore it. So the degree of that one is 0. And a degree of 0 means that there are no variables in this term. So a degree of 0 means no variables in this term. So we just found the degree of 4 different monomials. We're going to use that skill now to find the degree of polynomials. And just a reminder, we're going to calculate each term's degree, and then we figure out the biggest, and whichever one's the biggest overall, that's the degree of the whole polynomial. So I'm going to separate them at their pluses or their minuses, and then we're going to figure out each term separately. And remember, we're not going to look at the coefficients. So I'm also going to make sure that I'm not going to get tricked and think about the coefficients. Okay. Different colors. So for this one, it's just a 2. So the degree of this one is 2. X is by itself, it's a 1, so it has a degree of 1. So overall, the biggest is going to be, out of 2 and 1, the biggest is 2, so 2 wins for that one. Next one, we've got 2 and 3, so 2 plus 3 equals 5. Here, that x really has a ghosty 1, so that's going to be 1 plus 4, which also equals 5. And x and y both have exponents 1, so 1 plus 1 equals 2. So the maximum out of all of these, well, it's a tie. And if it's a tie, that's easy. It's still the max. That's going to be 5. For this one, it's trying to muck you up. So you got to do power of power rules on this one, and that means I have to multiply that first. Oh, and there's a ghosty 1. So here, I was using greens. So it's going to be 3 times 2, which is 6, plus 1. So on this side we get a 7, and here it's just 6. So overall, the biggest is 7. For this last one, we have power of powers again. So we got to multiply, and b is going to have a power of exponent 1. So here we have 2 plus 3, which is 5, plus 4 equals 9. Here we have 3 times 2 plus 1, which is 6 plus 1, which is 7. This one has 3 plus 3 plus 3, which also equals 9. So overall, our final degree is going to be 9. Okay. Next, not new idea, but practicing of an old one. To simplify a polynomial, we collect and combine like terms. So I'm going to use my highlighter to highlight the ones that are like terms. So these are z's. Z's are one of the ones I have to be careful writing because sometimes it looks like a 2. So if I was to write this out and be very careful, as a teacher, I might write minus 2z plus 4z and put them together. But I'm giving you permission to go straight. If you can recognize, if I take away 2 zebras and add back 4 zebras, I'm going to have a net of positive 2 zebras. But you don't have to write that line. If we have plus 3y, that's going to go along with a minus 4y. So we could write plus 3y minus 4y, but I'm going to choose to go just straight to minus 1y. I also could just write minus y. So it could be or. And then last but not least, we have minus 10x, and minus 3x. So again, not necessary to write them out, but if it helps you keep track of them, write them out. But take away 10x, take away 3x. Overall, we'd have minus 13x. This one I'm going to show you if I only had a pencil, what I would probably do. So I have y squared with another y squared, and this has a ghost 1 in front of it. So 1y squared, take away 5y squared is going to be minus 4y squared. And if you're having trouble with any of the arithmetic with integers, let me know and I can give you some extra practice. Here I've got a plus 2y cubed, and see how I'm keeping the sign of what comes after it? And then I've got another one that's another plus 1y cubed. So overall, I have plus 3y cubes. Our next questions want us to simplify and then evaluate. So simplify and then evaluate means first we're going to collect like terms, simplify first. So collect like terms, then evaluate. They're saying do all this and then figure it out when y equals minus 3. So in this case, evaluate is going to mean substitute. So for question 3, if we were to collect the like terms, I've got minus 6y, minus 9y, so minus 15y, minus 1 more y would give us minus 16y. And then they want to substitute wherever we see a y, we want to replace it with a number 3. Remember that squish together means multiply, so it's minus 16 times minus 3, so we get positive 48. For question 4, we're going to simplify first, which means collecting like terms. So we have minus 3 squared, and then there's another minus m squared, because remember the sign goes with whatever comes after it. So if I take away 3m squared and then take away 1 more m squared, I'll be at minus 4m squared. And then minus m plus 3m is going to leave me with plus 2m. And then they want substitute. So wherever I see an m, I'm going to put brackets this time. So minus 4 brackets, 0.5 squared plus 2 times 0.5. So minus 4 times 0.25 plus 2 times 0.5 is 1. Minus 4 times 0.25 also ends up being, but it's minus 1. So I get minus 1 plus 1, which equals 0. Okay, next, question 5 says write an expression for each perimeter. Perimeter means you add up going around the shape. So perimeter means adding the sides. And in the first shape, just a reminder that if we see these little tick marks, those are single tick marks. That means that this is also an x and that's an x. And if I were to add up the perimeter, it would have 3 x's. And then here, different color. Here, double cross, I don't even know what that's called. The double going across the line. So that means this is going to be a y and this is going to be a y. So we have 1, 2, 3 y's. So to be 3x plus 3y. And that'd be it. So for question B, for that double mark, I've got 4 of them. So that means all of those are y's. So that would mean our perimeter has 4y. And then we have x. And that'd be another x. So 1x, 2 x's. 6 wants us to do both the perimeter and the area. The perimeter we're going to do first because it's going to be most straightforward. I have an E here, another E here, another E here, another E here, all with the single lines. So the perimeter is going to equal 4E. And then I've got, it doesn't really show up that well, but that's a double, 3, 4, 5, 6, 7, 8. So it's going to be plus 8f. So the perimeter, pretty straightforward. Now the area is going to be a little bit trickier. For the area, I'm going to split this into 3 shapes. So I'm going to take this and I'm going to do a dotted line across here. And I know that the length of this is going to be the same f, but I'm going to call this shape 1 and this shape 2, and then this big longer one through the middle I'm going to call 3. So the area of section 1, which happens to equal the area of section 2, area of a rectangle is base times height. We know that its height is e and its base is f. So it's going to be E times F. We can just write that as EF. The area of section 3, we know it's got a height of F, and we know it's got a length of 1, 2, 3F. So it'd be F times 3F. When we're multiplying, if I have F times F, last unit we learned with exponents, so that'd be like f1 times f1. When the bases match, we add the exponents. So the 3 would stay out front, and then we have f to the 1 plus 1, so it'd be 3f squared. But they wanted the area of the whole thing. So overall, our total area, I'm going to go like this. Our total area is going to equal 1 plus 2 plus 3. 1 was EF, 2 was 3F squared, and 3 was another EF. And we can collect like terms because that and the plus EF are like terms. So that means 1 EF plus another EF means I have 2 EFs plus 3F squared. Coming back, stating the degree of each polynomial. I'm going to leave this one for us to do together as a class because it's going to be really important for us to do that. But I am going to move on really quickly and do some more of the simplifying. We're going to do 10 together in class, so I'm writing classwork. This one I want to practice number 11 now. And then number 12 will also be classwork. But for this one, I want to practice it because we're subtracting. That first one was adding, so those brackets are sort of gratuitous or extra brackets. But here, the fact that I want to subtract this second bracket from the first one means I got to be careful. And the first thing we're going to do is make sure that subtraction symbol gets distributed onto every part of that second bracket. So I'm going to start by not writing the brackets, going through doing any distributing. So the first bracket I can just take directly out of the brackets and write down minus 5n squared minus n minus 8. For the second one, I'm going to distribute that minus sign. A minus times a minus turns this into a plus 2n squared minus times 7n. Positive 7n is going to give me minus 7n, and then minus times negative 3, a minus turns into a plus 3. So first we do the distributing, and now we can collect like terms. So I've got minus 5n squared plus 2n squared. That's going to give me minus 3n squared. And remember, be brave and ask if you didn't understand what I just did there. Minus n squared, so the sign with what comes after it, with a minus 7n squared, gives us minus 8n. And then minus 8 plus 3 gives us minus 5. Last but not least, given the perimeter of the figure, so the perimeter is given right here, they want us to find the missing side length. So whatever this side length is, we don't know. We know that that question mark plus the other two have to add up to 7x squared plus 4x minus 7. So what I'm going to do is I'm going to see how much we get. So my first step 1, is going to be to add up our two known sides, our known sides. And if we add them up, let's see, I'm going to collect like terms. 3x squared plus 2x squared gives 5x squared. Different color. Minus 5x plus 3x is going to give me minus 2x. And then plus 2 plus 1 gives plus 3. So somehow those known sides plus some sort of unknown side, and that's what we're going to have to do a little bit of backwards thinking, is going to have to give us 7x squared plus 4x's minus 7. So we'll have to be thinking 5x squared plus something else gives us 7x squared. So that one's not too hard. And we could just think about it as, oh, hey, I subtracted 5x squared from 7x and got 2x squared. So that's one way to think about it. Or you might have just been able to figure it out. To start at minus 2x and end up at positive 4x squared, we have to add 6x. And to start at positive 3 and end up at minus 7, I would have to take away 10. And that's it for lesson 2.1. Thanks for watching.